Okay, this is the second part of lesson 1, chapter 1, lesson 1. We're going to talk about the distance formula now, and I already mentioned, I kind of alluded to this in the first part of the video, and now we get to it in the second part, and it's the distance formula, but we said you're going to see as we do this, it's really just the Pythagorean theorem. And our question is this. Say I have 2 points. I got my first point here, x1, y1, so that point right down here. Got a second point, x2, y2. The question is, how far apart are those 2 points? And how far apart in geometry when on a plane, where I was talking about the straight line distance, the shortest distance between 2 points is a straight line. So we're talking about the shortest distance. There's all sorts of ways to get from x1, y1 to x2, y2. We're talking about the shortest distance. So we're talking about that straight line distance. And when I think about these problems, I want to, you can see down here, here's the distance formula, that's what we're going to use, and you might remember that, or you may have been a little fuzzy on it. So you might remember that formula, and we'll use that. But I also want to explain where the formula comes from, because if you were fuzzy on the formula, if you remember where it comes from, you will never have any problems with this, and you won't really have to remember the problem. Or remember the formula, you can just kind of think through it logically and get the right answer. So I have x1, y1, and I have x2, y2. And I kind of think of this as city blocks that are laid out in nice squares and right angles. And I want to walk from x1, y1 to x2, y2. And if I do that, I'm not really allowed to take this straight line distance. If I did that, I'm cutting across people's yards. So instead, what I have to do to go from x1, y1 to x2, y2 is I have to walk along these straight streets. So I'd walk left and right, then I'd walk up and down. Something like that. And again, these are all right angles, so I can throw in a right angle in there. Well, when I do that, I walk left and right down here. The question is, how far did I walk left and right? What's that distance? Well, left and right are the x-coordinates. So there's x1, there's x2. What distance is that? It's x2 minus x1. I just take the difference between those two to get that distance. Going up and down, what's that distance? That's just y2 minus y1. And hopefully now you're looking at this and you're seeing a triangle in here. Look, it's right there. And you're seeing a right triangle because these are nice city blocks laid out at right angles. And you're thinking, why don't I take x2 minus x1 squared, add it on to y2 minus y1 squared, and wouldn't that give me the hypotenuse? Wouldn't it give me that straight line distance I'm looking for? And it would. And so that is where this formula comes from, the distance formula. It's really just a Pythagorean theorem. And again, you take the square root, because look, you're getting c squared and you want c. So to get rid of that square, you take the square root. All right, so we're going to use this distance formula, but like I said, if you think through it logically, it just, draw it out or go left, right, go up, down, and use your Pythagorean theorem, you are going to get it right every time without the formula. Okay, let's try one. And let's just sketch this out briefly just to see what we've got here. And maybe think through it intuitively, and then we'll use a distance formula. We've got a couple of points here. Oops, didn't leave myself enough space. One point is 2, 5, so roughly speaking here. The other point is 6, 8, so roughly speaking there. And the question is, what's the distance between those 2 points? Right there's that distance that we're looking for. And again, maybe let's just think through it and say, I'm not going across people's yards. I'm going left, right. I'm going up and down. Left, right, this distance is the difference between my x-coordinates. I went from 2 to 6. That distance is 4. Up, down. Those are my y-coordinates. I've got a 5 and an 8. That distance is 3. I've got this nice right triangle. You hopefully recognize that as Pythagorean triple. You've got a 3, a 4. The hypotenuse is going to be 5. So your distance will be 5 because that was a Pythagorean triple. You might be on the other end of it and say, no, I don't like that logical part. I want to use the formula. You can. You're going to think through it. You're going to be doing the identical steps with that formula, but let's try it. It's x2 minus x1 squared. So it's 6 minus 2 in a parenthesis squared. Then it's y2 minus y1. There's y1, there's y2. So it's an 8 minus 5 squared. And I complete the arithmetic here. 6 minus 2 is 4 squared. 8 minus 5 is 3 squared. Oh, look, I see that 3, 4, 5, but let's just work it out. There's a 16. There's a 9. 16 and 9 is 25. And the square root of 25 is 5. So the distance formula works if you want to remember that. Or if you just want to think through it and use your Pythagorean theorem. You know, get your left right, get your up down. It all works out the same. All right, another problem very similar. Here's point negative 3, comma 4, a 7, 0. What's the distance? Well, let's use our distance formula. I've got the square root. I've got a 7 minus a negative 3. And I've got a 0 minus a 4. Oops, a little sloppy, but I think you can still read that. 7 minus a negative, you know that's minus a negative is like plus a positive. So that gives me a 10. The 0 minus the 4 is a negative 4. And a negative, well, let's write that out, negative 4. I've got that negative 4 squared. The 10 squared is 100. And don't get fooled, the negative 4 squared is a positive 16. A negative times a negative is a positive. And I figure that out, and I get the square root of 116. And if I want to simplify that, what goes into 116? Well, 4 goes in 29 times. I know the square root of 4 is 2. I don't know the square root of 29, so I keep it inside the square root. So I get 2 square root of 29. You could also pull out your calculator and get a decimal approximation for that one. Okay, so that is our distance formula. Let's try just one more of these to cement it. And look at that. It's kind of a nasty looking distance formula problem because you got these square roots in here. And again, that's one of the values of taking trig is you learn some new things about solving triangles with trigonometry, but you review a bunch of algebra along the way. So let's use our distance formula. I've got negative square root of 7 minus 5 square root of 7. The whole thing squared. And then I've got 8 square root of 3 minus a negative square root of 3. Whole thing squared again. Okay, good practice without a calculator to do this. And then I want to do this negative square root of 7 minus 5 square root of 7. And had I written negative x minus 5x, I don't think you guys would hesitate. I think you know exactly what that is. Negative x is like negative 1x minus 5x, and negative 1 minus 5 is, you'd say negative 6x. Well, it's the same thing here with our square roots. Here's negative 1 square root of 7 minus 5 square root of 7. What is that going to give me? That's going to give me negative 6 square root of 7. That whole thing is going to be squared. And then similar over here with the second part, I've got 8 square root of 3 minus a negative is like plus. There's 1 in front here. So 8 root 3 and a 1 root 3 is a 9 root 3. So I've got 9 square root of 3 squared. And now I need to square both of these. And again, we're getting some nice algebra review in here. The square outside of parentheses goes to both parts here. So let's see if we can get this. The negative 6 squared is 36. Maybe put a little arrow down there. So a negative times a negative is a positive. Don't let that fool you. And the 6 times 6 is 36. All right. The square root of 7 squared is how much? The square root of 7 squared is 7. And I used to love to do that to algebra students. Hopefully it wasn't you, because I didn't teach algebra a couple of years ago. But I'd give them something really nasty, looking like the square root of 117. I'd ask them to square it, and I'd say, and by the way, you are not allowed to touch your calculator. And certain kids would get the trick and get the answer immediately, and other kids were just really confused. But the trick is this. A square root, right here, a square root, and a square cancel out. And the answer is 117. So the same thing just happened over here. Square root of 7 squared is 7. All right, let's do the second one over here. 9 squared, keep our arrows here so we can see what's going on. 9 squared is 81. The square root of 3 squared is 3. We'll continue doing some arithmetic. We know we multiply before we add or subtract. So 36 times 7 looks like a 252. And an 81 times a 3 is a 243. I add those up and it looks like a 495. All right, can you think of any perfect squares that go into 495? How about 9? How many times does 9 go in? 9 goes in 55 times. And what's the square root of 9? 3. What's the square root of 55? I don't know. So keep it inside the square root. And so that would simplify to 3 square root of 55. All right, that's our second part here. That takes care of our distance formula. There's one more little part left, which just shows you a couple of the trickier problems. It shows you, I'm going to give you 3 points how you do that. And it also shows you a word problem that's kind of clever. But this is our second main concept here, which was the distance formula.